Okay, so today we're going to solve some limits. Our first limit is the limit as x approaches 1 of the cube root of x minus 1 all over x minus 1. So the first thing to do with this limit is we're going to change the way our denominator looks. So we can keep the numerator the same, but we can write the denominator in terms of the cube root of x. And it'd just be the cube root of x cubed minus 1. And now we can see that there is a difference of cubes in the denominator, and we know how to factor that. So that's going to be the same as the limit as x approaches 1 of the cube root of x minus 1 all over the cube root of x minus 1, sorry, it's a cubed, times the cube root of x squared plus the cube root of x plus 1. And so these two cube root of x minus 1s are going to cancel out in both the numerator and the denominator. And then we get a simple expression, the limit as x approaches 1 of 1 over the cube root of x squared plus the cube root of x plus 1. And that converges to 1 over 3. So moving on, we have a limit that involves fractions. And the first thing we're going to do with this limit is we can change the way the numerator looks such that we're going to try to get rid of this x plus 5 term, right? So we can say that this equals the limit as x approaches negative 5 of, if we combine the numerator, it's going to be 3 times that first term plus x plus 2 times that second term, right? So we'd get 3 plus x plus 2 all over 3x plus 6. Oh, and sorry, all over x plus 5. This is the numerator. And so we can see that the numerator is now x plus 5. And in the denominator, we also have an x plus 5. So those two will cancel out. And this limit will read the limit as x approaches negative 5 of 1 over 3x plus 6. And by just substitution, we can plug in negative 5, and we get this equals negative 1 over 9. All right, moving on, we have a limit involving trig, which will be the limit as x approaches 0 of cosine squared x minus 2 sine x minus 1 all over x. And we can say that, we can see that there's both a cosine and a sine, and we're going to want to get rid of one of these. And I'd say the easiest one to get rid of is this cosine. We can set cosine squared x equal to 1 minus sine squared x, such that this limit can be rewritten as the limit as x approaches 0 of negative sine squared x minus 2 sine x all over x. And from here, we can take one of our special limits out. We know that the limit as x approaches 0 of sine x over x is just 1, as they both behave the same as both functions approach 1. And by substituting that out, we get the limit as x approaches 0 of negative sine x minus 2. We can solve this limit as by substitution, we plug in 0, we get that limit's equal to negative 2. And we know 1 times negative 2 equals negative 2. That's our answer. All right, now we have an infinite limit. And the first thing to do with an infinite limit is to check the domain of everything in the limit, right? Because you would need to make sure that this limit does actually exist. And we can see here that it's going to exist for all these polynomial terms. There's a constant term, but there's a natural log term. The natural log has a domain of 0 to infinity. And we can see that negative infinity isn't in that domain, such that this limit does not exist. All right, another infinite limit here. We have the limit as x approaches infinity of e to the x squared minus x to the 5th plus 1 all over e to the x plus 3 to the negative x. And we can check that this limit has no domain restrictions. So we can then approximate this limit by taking the fastest growing terms in the numerator and the denominator. In the numerator, e to the x squared grows a lot faster than x to the 5th. So we can leave just an e to the x squared all over, and the denominator, 3 to the x is increasing while 3 to the negative x is actually a decay. So it's just e to the x. This is equal to e to the x squared minus x, and we know that the limit as x approaches infinity of e to the x squared minus x will be positive infinity. And that's all. Thanks.